Thank you, Black Hat, for having me. It is excellent to be here among all you wonderful people. Again, I apologize, my voice is a little rough today, but it's a good thing that I have a voice at all. I did training here at Black Hat for 4 days, and it turns out I get really excited when I talk to people about math, and woo, math. Anyway, I talked to a big room full of people about math for 4 days straight and then completely lost my voice, but it's coming back. It's working its way back. It's a little intimidating having myself like 50 feet tall over there, but at least that means that, that you guys can all see my swank NSA Playset t-shirt. Woo! Yeah. The NSA Playset started about 1.5 years ago in our heads. Before I get going too much, I want to give you a little caution. Well, less of a caution than I've had in some of my previous talks about the project. This presentation includes no content from leaked classified documents. So those of you who are hanging out in the back of the room wondering if you can stay, maybe you can. Sometimes some of the talks that we've given, myself and others in the NSA Playset project, some of these talks have included leaked classified content because this project was inspired in great part by leaked classified content. But today I want to talk about what we've created in the project and not so much about what inspired us or anything that might be troublesome for some people to hear. And it's kind of interesting, actually. I think, especially folks in foreign countries, I find are quite intrigued by this whole phenomenon that we get information leaked from the government, classified information, that is, and other folks within the government who have a security clearance are most of the time asked to avoid it, to not read it, to not have copies of that leaked content on their computers. It creates a bureaucratic hassle for them and is a violation of rules to actually have classified content that they're not explicitly authorized for. And so sometimes we've seen leaks of information that is useful to us in the security community that informs us about threats that maybe we didn't consider before. And we, as the security community as a whole, have the benefit to learn something from these leaks. I'm not talking about learning what our government is up to. I'm talking about technical learning or learning about how threats that maybe we should be aware of and maybe we should take into consideration when we're developing defenses for our own systems. And of course, there are many, many fine people working for the government doing good work who have their own systems to defend, and a tiny, tiny fraction of them are able to learn about those threats in the same way that the rest of us are. It's a strange thing that in many cases folks who have a security clearance end up being in the dark more than some other folks. So sometimes I set out to tell people about these leaks or the content, the things I've learned from the leaks rather. And sometimes I try to avoid talking about those leaks so that I can give information in general or about the types of threats that I've learned about from the leaks, maybe in part, but in a form that can be consumed by folks who aren't otherwise able to consume the leak information directly. So this presentation includes no content from leaked classified documents. I won't talk about any details or show any screenshots from leaked classified documents, but I will mention the leak. I'll just talk about it in general terms a little bit, but I'm not going to give you any content from that leak. So in other words, it's only metadata. So right at the end of 2013, we saw the leaked ant catalog. And this is not a page from the ant catalog. This is a page I did for fun, inspired by the ant catalog, made to look like a page from the ant catalog. So there's nothing here that's actual content from the ant catalog. But it looks, a fair bit like something from the ant catalog. And it was a leak that contained a bunch of these pages of information. The APT Catalog from the NSA. And so this was about a year and a half ago. And folks in the security community had a lot of fun with going through the tools in that catalog, which included all kinds of hardware and software tools that are of interest to the information security community. And it was interesting, I think, to see people's reactions to it. Sometimes folks were, I think a lot of folks were a bit unsurprised by a lot of the tools in the catalog. There were a lot of things in there that were capabilities that the information security, the public information security community, the research community, the hacker community, we already had a lot of these tools or things that were somewhat similar to those tools. And we didn't see, for the most part, a whole lot of earth-shattering things in there, but it was still pretty neat to see the stuff that the spooks use. My first impression, as I was reading it, my very first impression was, wow, we can do all this stuff. Everything in here we already know how to do, or isn't much of a stretch, isn't much of a leap. And then my second impression was kind of like, for the few things that were in there that were new to me, I thought, why haven't I seen these things before? This is kind of a gap maybe in the research that and in the public information that we have in the hacker community. In some cases, some of the stuff that was in the ant catalog was kind of like, you look at it and say, if you have any kind of technical background, you look at it and say, yeah, it's kind of obvious that should be possible to do, but you know what? Has anyone actually done it? Has anyone showed this stuff at a con? Has anyone written a research paper on these particular techniques? And in some cases, the answer was no. There were things in there that, while being unsurprising in some ways, were also new and hadn't been talked about publicly. And that was one of the things that inspired me to start thinking about the NSA Playset project. And in particular, I wanted to give a talk about how we can build these tools, the same tools like the nation states use, and we can build them ourselves in the open research community, in the hacker community. We can build them out of open source hardware. We can build them out of open source software. We can build them out of off-the-shelf hardware and software, and have easily accessible tools that people can use, at least to serve as a demonstration of threats that folks might not have considered before. And I thought of this, and I ended up doing a talk last May of 2014. Was the first talk on the NSA Playset, and I gave this talk, and it was about here are my ideas. I went through the whole catalog, the entire catalog, and I focused on the hardware tools, and I said, here's what they have, and here are some ideas for how we can build these things. And it was sort of a pre-project talk. It was just sharing my ideas for how these things can be built. But originally I didn't conceive of the idea that we would actually go and build them necessarily. I just wanted people to be aware that they could be built. So when I was preparing for that talk, the first thing I did was I emailed Dean Pierce. This is a picture I found on Twitter of him. And the reason I chose this picture is because he's wearing a POC or GTFO t-shirt, POC or GTFO, and many of you, I hope, are familiar with the International Journal of POC or GTFO, and this picture was taken years before the International Journal of POC or GTFO, by which I mean to point out that Dean is a man ahead of his time. And he had actually coined the term the NSA Playset also years before. And so when I had this idea for this talk last year, I wrote to Dean immediately and I said, hey Dean, can I use the name the NSA Playset for this talk? And he said, sure. And let's start a wiki and let's get other people involved and let's actually build these things and let's just make a whole lot of fun stuff. So it's in great part thanks to Dean that many of us have joined the project and contributed in various ways, and we've gone way beyond just thinking about how we can build tools like the spooks use, but actually building them. And so what I'm here today to do about a year later after the first NSA Playset talk is to tell you about the things that we have in fact built. This is one of my favorite ones, and this was presented at DEF CON last year. Actually, I have it in this box up here, it's a tool called Slot Screamer that Joe and Miles talked about, and it is a PCI Express attack tool. And there are a number of ways it could be used. One idea is that it could be implanted into a computer. And this device allows you to implement a PCI Express device that then has the ability to for example, access the memory bus on the computer. And one of the great things about this particular implementation is actually the device that you see on screen here is a PCI Express to USB 3.0 bridge. And it's fascinating. It's built on this interesting chip. And you can buy this board online very easily. And it's based on this chip that serves as a USB device and also as a PCI Express device. Which is a little bit funny because it means you can maybe take an attack laptop and connect through your attacker's USB port to this guy and control or emulate a PCI Express device actually in software on your laptop if you want. It can also work the other way around. If you plug this into the attacker's PCI Express slot, you can use it as a USB device to attack a USB host. But in the particular implementation that Joe and Miles showed, they did things like put this device into a chassis, a Thunderbolt PCI Express chassis, and then they were able to, from their attack laptop connected via USB to Slot Screamer, they were then able to implement an attack against Thunderbolt on a system. And so they could just plug into the Thunderbolt port on a laptop and like read and write its memory, which is an extremely powerful attack. And in many cases, there are, well, in a growing number of cases, there are actually countermeasures to this sort of attack on Thunderbolt and PCI Express. But there are definitely cases where there are devices that are entirely vulnerable to that kind of thing. The tool that they were using, at least for part of their attacks, was Inception, which has been around for a long time. I think originally just for FireWire, and you could do direct memory attacks kind of over a FireWire port. And now Inception has support for this device. Joe just got his chassis off the shelf the other day and like downloaded the latest version of Inception and plugged it all in, and it worked perfectly for his demo. Wagon is another kind of hardware implant. And the idea here, and again, this was presented at DEF CON last year by Josh and Teddy. The idea here is to take advantage of a bus on your computer that a lot of people don't even realize is there. It's called I2C or I2C. And folks who do electronic design use I2C all the time. I've used it on the HackRF design, for example. If you have a couple of different integrated circuits on a board and they need to talk to each other, I2C is one of the common ways to do that. So, of course, there are I2C buses on PC motherboards of all sorts. And it's a bus that is generally exposed to the operating system. So, like in the Linux kernel, you can look in the proc file system or sys file system or your dev file system, and you can find interfaces through your kernel to talk to I2C devices that are connected one way or another to your computer. Now, one thing that a lot of people don't realize is that some I2C buses are exposed on the outside of your computer, including in the form of a couple of pins on your VGA cable, if you have a VGA port. And there is also an I2C bus that's part of the HDMI standard. So if you have an HDMI port on your computer, you have external access, physical access to this bus. And the idea with Chuckwagon was that that's a convenient interface for if you wanted to build an implant that you would install in somebody's computer surreptitiously, and you could then create an interface like a communications interface for malware that's running on that computer. So it's a piece of hardware, a little implant that the malware can talk to over I2C. And Chuckwagon is just kind of a prototype thing, and they decided to build it using that VGA port so they could just attach it externally to any computer that has a VGA port. And what they added to it, the capability that they were giving to the system was communication. So they had for example, they showed how they could put a GSM modem in there, a data connection, cellular data connection, and allow malware to have this back channel, the covert channel over a cellular network. And as long as you have one time the ability to install something like this in somebody's computer or attach to somebody's computer, then you have a covert network into that computer or out of that computer. Turnip School was one that I didn't think was going to be possible at first when Dominic and I first started talking about it. It's a USB cable that we installed a covert RF interface into. So kind of the same concept as Chuckwagon, kind of the same concept that there might be malware on the computer, but how do we control that malware, or how do we exfiltrate data from that malware? What channel do we have, especially if there's an air gap? And this is kind of a cool idea that we could take a low-cost digital radio transceiver chip, like the one that's in the popular IME, and actually implant it inside a USB cable, hide it inside a USB cable, so that we create over the USB port a covert channel, a covert radio channel. Now this also has the possibility of being used to implement USB attacks. If there isn't malware running on the host computer, you could actually radio control this device that is plugged into a USB port and implement attacks against the USB host. And that might be a way, like some of these other tools could be a way to gain malware persistence on a host. It's a very powerful thing when you have a hardware implant into a PC, and it has the capability to attack the operating system in some way. Because that means you can have malware running on the system, and even if it's detected, even if it's cleaned up and totally removed from the operating system, then you can always, the attacker can just re-implant that malware from the hardware implant. So that's one of the potential purposes or use cases for Turnip School. Now, Turnip School ended up totally working. And it's based on the Yardstick 1 design. Yardstick 1 is an open source hardware project that I'm talking about later today at Arsenal. And what we did was we took the chip from Yardstick 1, which is in the same family of parts from the I Am Me, my favorite pink toy, and we put it on a tiny little circuit board that fits inside the male A connector, the A plug, USB A plug. So there's that one little chip that's a combination microcontroller, USB device, and radio. And then there's a second chip on the other side of the board that is a USB hub. And the USB hub allows this cable to kind of appear at first glance to work like a regular USB cable, because you plug it in, and through the hub, the device plugged into the other end of the cable works normally. Now, if you look closely, you might notice that there are a couple of USB devices that you weren't expecting, but how many people actually list out all their USB devices every time they plug in a cable? So this picture was taken just before I encased the thing with an overmold boot that was made out of a hand-formable black silicone. And Dominic, when he finally convinced me that we could do this project, he said, yeah, you know, I think we can do it. I think we can fit all that stuff into a USB plug. And he said, you know, I might even take a crack at that. He doesn't do a lot of electronics design, but he thought he'd give it a shot. And I said, I tell you what, Dominic, if you do the schematic, I'll do the PCB layout. And I really got the raw end of that deal, because this layout was tough, but it worked. Tiny Alamo was something that Mike Ryan talked about last year at the DEF CON Wireless Village, and this was really more of a software attack. He used Ubertooth as part of the project, and he also used an off-the-shelf Bluetooth dongle. He was able to do some reconnaissance with Ubertooth, and then implement an attack using just a regular old Bluetooth interface, Bluetooth dongle, or maybe even one built into a laptop. And what he was targeting was keyboards and mice. And it turns out that there are some Bluetooth keyboards and mice. Of course, you've probably seen those before. They're a lot more popular since the advent of tablets. And there are also, fairly recently, some Bluetooth low energy keyboards and mice starting to show up. They're a little rare compared to classic Bluetooth input devices, but they're starting to show up, especially mice. And what he discovered, and I highly recommend checking out any of his talks on Bluetooth low energy security, of which he's given several. And what he discovered in the case of this particular device is that the mouse he was looking at really had no security features whatsoever. And so he could just spoof the mouse and inject input events into a computer. And here's an interesting point about this type of attack. When you're able to spoof a wireless mouse, in most cases you can actually inject keystrokes, because the driver on the host doesn't really care what kind of device you are. You can inject any kind of device, any kind of input using the USB HID protocol, or Human Input Device Protocol. And so in this case, he was able to take a device that was just a mouse. And you know, if you're using a mouse, or if you're manufacturing a mouse, you might think, well, a mouse isn't too terribly security sensitive. You know, yeah, there's some exposure there, but like, you can't sniff keystrokes from a mouse, for example, very easily. So you might kind of punt on the security measures. And Mike showed that using the Tiny Alamo project, he showed that you can actually take that vulnerable mouse and do something much more powerful with it. You can spoof it and start injecting keystrokes, not just mouse events. Keysweeper was an internet favorite, and Sammy did this wonderful device. It looks just like a USB charger that you plug into the wall. And it in fact is a USB charger. But he put some other stuff inside of it. He took an attack that was originally implemented some years ago by Travis Goodspeed, an attack that allowed the monitoring, the sniffing of keystrokes from wireless keyboards. Again, we're looking at keyboards with this tool. You can sniff wireless keystrokes from a number of Microsoft wireless keyboards quite easily. And again, this is a case where there are input devices that don't have very good security. So Sammy took this attack and shrunk it down and stuck it into a tiny little package. In this package is a sniffer, a wireless sniffer that sniffs the keystrokes. And there's also a GSM module that allows him to send those keystrokes over a cellular network to wherever he wants. And it also still functions as a USB charger. And he fit all this into a little, well, a somewhat bulky, off-the-shelf USB charger, which means, of course, it's easy to plug in somewhere, which is where it gets its power, and people are unlikely to notice that anything is amiss. This is an example of one project within the NSA Playset that wasn't even originally conceived to be a part of the NSA Playset. Sammy kind of did this on his own and published some information about it, and some folks from the NSA Playset project contacted him and said, "Hey, Sammy, this is great for the NSA Playset. Can we put it in there?" And he said, "Yeah, I'll do that. Okay." So Sammy's giving a talk on some really cool stuff that he's been doing more recently, coming up this weekend. Also, I should pimp some other talks. I'm gonna go back a little bit here. Joe is giving a talk this weekend that I'll talk about a little bit later. And let's see, who else is giving a talk? Mike Ryan and Richo are doing a wonderful talk on hacking skateboards coming up. More Bluetooth madness from him. And Sammy's doing a talk this weekend on some interesting automotive-related research that he's been doing. Leviticus is a handheld spectrum analyzer. And here's an example of something that existed before we conceived of the NSA Playset. And we just thought it fits so nicely into our project, we're going to give it a silly name and put it into our project. But this is an older mobile phone using the Calypso chipset, and the various hackers who have learned to write code for that chipset have over the years released some interesting little tools. And there's one that a lot of folks aren't aware of, I don't think, is that there's a tool to measure the RSSI, the received signal strength indicator, from the baseband. And you can tune the radio to a frequency, measure the RSSI, move on to the next frequency, measure the RSSI, and so forth, and do a live spectrum analyzer application with limited radio bandwidth embedded in a mobile phone. And I think it's really cool that you can take an off-the-shelf mobile phone and do such a thing. This requires no hardware modification whatsoever. It's only software using off-the-shelf hardware. Also, mobile spectrum analyzer or handheld spectrum analyzer applications, which are, super handy for implementing all sorts of radio shenanigans. I wrote this one for the IME, my favorite pink toy, as I mentioned before. I wrote this spectrum analyzer application some years ago, shortly after Travis Goodspeed introduced me to the device. And at the time, I was able to find one on eBay for $16. But since a couple months ago, Sammy published his brute force garage door opener attack on the IME. Now they're going for like 300. So I have a few on my shelf, and I'm thinking by next year I might be able to retire with them at the rate this is going. But this was a children's toy that you could buy on eBay, at least until recently, for pretty affordable prices. Like I found most of mine for like $20 to $30. And similar to the Leviticus, it's a handheld spectrum analyzer. And also similar to Leviticus, there's no hardware modification required. This is an off-the-shelf children's toy with a highly capable radio in it that can tune to quite a range of frequencies in the sub 1 gigahertz bands, including all the popular ISM bands like the 900 megahertz ISM and 433 megahertz, and the bands that are used by remote keyless entry systems, including garage door openers and cellular bands. All kinds of fun stuff can be done with this little radio chip that is inside the IME. And it's the same family of chip that we used in Yardstick 1 and in Turnip School. So this chip from ChipCon is the gift that keeps on giving for sub-gigahertz radio hackers. And so I throw this in here because I was thinking, oh, I put Leviticus in there. I really should put the IME spec in the Playset catalog too. But I just threw this into my slides like 45 minutes ago, and we don't have a silly name for it yet. So we need a silly name for this. If anyone has any suggestions, I'd love to hear from you, and we'll give it a silly name and put it into the NSA Playset wiki that's online at nsaplayset.org. Twilight Vegetable, that's one of my favorite names too. Twilight Vegetable is a tool that Dean and Loki talked about last year, and it is really basic in terms of the hardware. It's off the shelf. It's just an off-the-shelf USB stick that comes with a special purpose Linux distribution that has all the software you need to do GSM sniffing. And you can use Twilight Vegetable with a $20 Realtek TV tuner dongle. All you need is just the USB stick with the code and the USB stick for your TV tuning. And you plug them into a laptop, boot off the USB stick, boot off Twilight Vegetable, and it gives you all the software you need to start sniffing mobile phone traffic. Now, what do you do with that mobile phone traffic? Well, you use your Drizzle Chair, which is, I think that's a play on Rainbow Table, because Drizzle Chair, again, is just off-the-shelf hardware. It's a large hard drive that includes GSM rainbow tables for decrypting the GSM communication. And I'm not sure that people realize how easy it is to capture and decrypt GSM traffic. All you need is Twilight Vegetable and Drizzle Chair. And so in this case, they weren't talking about any attack that hadn't been published before. All they were doing, what they were trying to accomplish as part of the NSA Playset project, was making the tools more accessible and showing people how easy it is to accomplish some of these things. Yes, people have been sniffing GSM for years. Yes, people have been cracking GSM for years. But did you know that you could do this on your laptop that you're carrying around with you just by having the right software and the right 1 terabyte hard drive and a $20 TV tuner dongle? It's pretty cool. And it's pretty cool that they're able to help people see that this type of thing is possible and very accessible attack. And that's a big reason, a big motivator that we wanted to do the NSA Playset project, was because we wanted to show people the stuff that the nation state actors, the tools that they use, the gadgets they have, they're nifty, but we can do that too. We can do all of those things. Porcupine Masquerade, I never actually saw flying around DEF CON last year, but I think it was at one point. But Darren and Peter posted this on our mailing list one day, like right before DEF CON, and said, "Oh, we're bringing Porcupine Masquerade," and it's just it's basically just a flying Wi-Fi pineapple, which, you know, it's just a obvious but kind of silly thing. But you know what? We have some wonderful tools for Wi-Fi in the security community. We have Kismet, for example, open source software is a fantastic tool for monitoring Wi-Fi communications. We have readily accessible tools like the Wi-Fi Pineapple and all kinds of special purpose tools for Wi-Fi hacking, but also general purpose hardware and software. The Wi-Fi cards and chips that we have in our everyday devices in many cases are perfectly capable of implementing all sorts of shenanigans. And we're kind of lucky in some sense that Wi-Fi works out that way. A lot of other radio protocols, and this is what I spend a lot of time talking about and doing research on and teaching people about, a lot of other radio systems are a little less accessible, a little harder to, or in some cases a lot harder to have tools for, develop tools for. But in the case of Wi-Fi, we have amazing tools in just off-the-shelf hardware. And this is an example of using just some off-the-shelf hardware, which is a little bit customized. And being able to fly around. And you could do something like have this thing automatically follow a person who has a particular MAC address, or, you know, use your imagination. Congo Flock was the first RF retro reflector that I built. And this is an area of research that I think is very important for the security community going forward, at least in my opinion. And I talked about this last year. I started talking about it. And I've given a couple of talks here and there on RF retro reflectors. The interesting thing here is that this is a device that is, what is that, about a ½ centimeter wide. And that's really much bigger than it needs to be. The only reason it's that big is because that was the minimum size PCB I could get made. And I wanted it on a printed circuit board for convenience in experimenting with it. But really this device consists of only one component, one transistor and 2 pieces of wire to serve as an antenna. And what you do with Congo Flock is you implant it in some hardware. For example, a cable. You implant it into a cable, or you implant it into a monitor, or you implant it into a keyboard or into a PC, any kind of electronic device that has any sort of signal that goes over a wire. If there's a wire or a trace on a circuit board that you want to tap, if you want to monitor, you connect it to Congo Flock. And what it does is it creates an opportunity for an attacker to eavesdrop on the signal on that wire using radar. So this device requires no power supply. It makes no radio transmission on its own, but it modulates its reflectivity, its radio reflectivity, according to the signal on the wire that it's connected to. And so what you do as an attacker is you have one of these implanted somewhere. Like imagine that this is implanted in a keyboard cable. Okay, so you just have to swap somebody's keyboard cable. And then it just sits quietly and does nothing until the attacker from somewhere nearby, maybe within 100 meters-ish, directs a radio signal at the device and then measures the reflected radio signal using very traditional radar equipment. With this technique, the attacker can observe the signal on the wire and do things like sniffing keystrokes, sniffing video screens if you put this on a video cable, etc. This was the first retroreflector I built, and I think I intentionally set out to make it the simplest possible device from which we can experiment, a starting point from which we can grow and try other types of retroreflectors. There's been a fair amount of research, published research, on the subject of unintentional emissions from from electronic systems, electronic devices, digital electronics primarily, and video screens. And if you're interested in this sort of thing, I recommend starting with the papers by Marcus Kuhn on the subject. But while we've had research on the subject of unintentional emissions, we haven't had published research on the subject of emission security based on reflected radio signals. And this is just a stepping stone, I think, because here we have an intentional implant, something that is put into a device or put into a cable that is an intentional RF retroreflector that reveals information about the system that it's attached to by means of radar. But it's entirely probable that there are situations where our everyday electronic devices have unintentional RF retroreflectors in them. That without even knowing it, the designer of a product, of an electronic device, might have created a system that can be eavesdropped on through radar without having to modify the hardware in any way. I haven't found any of those yet, but I speculate that they exist, and that if people start poking around, that we will actually find them. And so a good place to start experimenting is with these custom-made RF retroreflectors that are designed specifically to intentionally serve as retroreflectors. So Congo Flock I've used to sniff PS2 keyboards, for example, and USB a little bit. Then I started building some slightly larger ones, and the only reason they're larger is because I wanted to have connectors on them, which makes them easy to experiment with, plug them into different types of cables. And this is one, Tangle Flock, is used to monitor USB connections. This only works at low speed and full speed USB, not high or super speed USB. But this includes, for example, all USB keyboards and mice. Flamenco Flock, I've had a lot of success with, and I've demoed publicly a few times. And it's a PS2. Same exact circuit, one transistor, just on a convenient form factor to plug into PS2 cables and demonstrate sniffing PS2 keyboard keystrokes this way. Now Salsa Flock is a little bit more complicated. I wanted to sniff VGA signals, and I wanted to show that it's possible to use an RF retroreflector to allow an attacker to recover the image on a screen with radar. So I want to give you a little demo here. This isn't a live demo. I didn't set up my radar and everything, but I want to show you the data that I get out of this attack. I fire a radar at Salsa Flock, which is implanted in a target VGA system, and then I measure the return signal. I'm using software-defined radio. I'm using the HackRF platform to implement this, but it can be used. It could be implemented with virtually any radar type of system that has the ability to digitize enough radio bandwidth. So let me show you what I get out of it. I get this nonsense. And I have a very simple digital signal processing implementation where I take the received data from my HackRF and I simply measure its amplitude. I do amplitude demodulation. And then I dump the demodulated output into a file. And then I open the file with something like GIMP. And GIMP has, this is open source software that lets me simply open the file and then give it different parameters for how wide and high I expect the image to be, and lets me do some things just say, wow, is there an image there? Well, I'll just try to rasterize it with a bunch of different widths and see what happens. And so I go through and I try a bunch of different widths, and you can see there's definitely some structure there. This is an actual image that I got in my lab from doing a pretty close range RF retro reflector test with Salsa Flock. So as I get closer to the proper resolution, boom, an image pops out at me. You can see I was targeting a Pen2 Linux screen. And you can see I was running XR&R to change my screen resolution before I ran this test. And as I scroll through here, you can see actually there are thousands of images of this screen. Oh, then like something broke, or I moved something, an antenna or something, and then it came back. There are thousands of copies of the same screen in here. So even though it isn't particularly easy to read, you can see that there's so much redundant information because my screen refresh rate is something like, in the target, something like 60 refreshes per second. Well, if you're trying to read text off of somebody's screen, how often does that text change? It's not changing 60 times per second. So you get a lot, as an attacker, you get a lot of redundant information. Over and over and over again, I get these kind of poor images, even though in many cases they're readable. I get these kind of marginal images of the target system screen, and I could combine those multiple frames of information together after the fact if I wanted to. So in the future, I'm not entirely sure what's going to happen with the NSA Playset project, but I hope that people learn from it. And maybe we'll have more Playset tools. Certainly we're having more this week. In particular, just the other day at B-Sides, Rootkiller presented Blinker Cough, which is a covert channel implemented through optical data transmission built into a VGA cable. And so he built this custom little circuit board. And it's a little funny that it has that long photodiode there, or phototransistor sticking out, but that can be made smaller. And he actually talked about how he could create networks of these things, like a mesh network, a covert channel among the VGA cables that have all been replaced in an installation. So this is just one example of something that's happening just this week that I didn't get into my talk until this morning, but it's a part of the NSA Playset project that is part of ongoing work to help people see the kinds of tools that could be used. Another one is coming up this weekend. Joe Fitz is giving a talk on his JTAG implant that goes in PCs called Solder Peak. And I have some Solder Peak PCBs with me up here that I will try to remember to give back to him before his talk. So we have some things going on still in the NSA Playset project. But I thought that the 1 year mark was kind of a good time to take a step back and look at all the things that we've built. It's a group of people that is loosely organized. Anybody can join us. Anybody can go to nsaplayset.org, contribute your own project, join our mailing list. I would like to see going forward more retroreflector research, either done by myself or done by other folks. I think it's an important area that I hope the NSA Playset can inspire people to get into as a research area. And one last thought is that one thing we should consider is that the things we're creating, the things we've created already, might actually be used by nation-state actors. Instead of using tools that they develop on their own, it's interesting to consider that they might end up using the very ones that we use, which could give them the benefit of plausible deniability in some cases. So that's an interesting implication of this project that I don't know people have thought about necessarily before, but I find intriguing. So thank you to Dean Pierce for coming up with the name NSA Playset, and Nick for drawing some really cool pictures that I've used in some of my presentations, and Rootkiller for making these awesome t-shirts, and everyone in the NSA Playset crew, in particular everyone that I mentioned that was listed on slides today, who've contributed something to be part of the NSA Playset. It is a group effort. and it's a lot of people having fun and also trying to find a fun way to educate the community. So check out nsaplayset.org. Here are some of Nick's drawings, and I hope you'll enjoy some of the tools that we've done already, and I hope that some of you are inspired to contribute in the future. Thank you.